Good morning, everyone, and welcome to Module 2. In this module, we are going to explore one of the most important foundations of modern decision making, the relationship between data, evidence, and analysis. Across business, healthcare, cybersecurity, government, education, engineering, and scientific research, organizations increasingly rely on analytical systems to guide strategic and operational decisions. However, the quality of those decisions depends heavily on the quality of the underlying data and on our ability to interpret analytical evidence responsibly and critically. As we move through this module, I want you to think carefully about a simple but extremely important question. When we look at charts, dashboards, reports, or predictive models, how do we know whether the conclusions being presented are actually trustworthy? Many people assume that if information appears in a professional report or inside a sophisticated dashboard, then it must automatically be correct. In reality, analytical outputs are only as reliable as the data collection methods, assumptions, measurement processes, and analytical techniques used to produce them. This means that understanding data is not simply a technical skill, it is also a critical thinking skill. One of the key themes we will examine is data quality. High quality data is accurate, complete, consistent, relevant, and reliable. Poor quality data, on the other hand, can introduce bias, confusion, and uncertainty into analytical systems. A flawed data set can produce misleading trends, inaccurate forecasts, or incorrect conclusions that ultimately lead organizations toward poor decisions. In many real-world environments, decision makers are forced to work with incomplete or imperfect information, which means they must understand both the strengths and limitations of the evidence they are using. We will also explore the role of analytical evidence in reports and dashboards. Modern organizations generate enormous amounts of data every day, but raw data alone has little value unless it can be organized and interpreted effectively. Reports, visualizations, dashboards, and performance metrics are designed to transform large data sets into understandable forms that support decision making. However, visualizations can sometimes distort reality if scales are manipulated, if important context is omitted, or if selective information is presented in misleading ways. Because of this, decision makers must learn how to interpret evidence critically rather than accepting every chart or graph at face value. Another major focus of this module involves understanding data limitations. Real-world data is rarely perfect. Data sets may contain missing information, measurement errors, inconsistencies, or sampling bias. Certain populations may be underrepresented, sensors may produce inaccurate readings, surveys may contain poorly worded questions, and numerical information may fail to capture important human or organizational factors. Recognizing these limitations is essential because analytical systems cannot magically eliminate the weaknesses present in the original data. Instead, those weaknesses often become amplified when decisions are made at scale. In addition, we will discuss the credibility of data sources. Not all sources are equally trustworthy. Some datasets originate from highly reputable institutions that use transparent methodologies and rigorous quality controls, while others may come from unverified or biased sources with unclear collection procedures. As future professionals and analysts, you must develop the ability to evaluate whether a source is current, transparent, reliable, and methodologically sound before using it to support important decisions. By the end of this module, you should have a stronger understanding of how data quality influences analytical outcomes, how analytical evidence should be interpreted, how data limitations affect accuracy, and how source credibility impacts trust in decision-making processes. These concepts form the intellectual foundation for responsible analytics, evidence-based reasoning, and ethical decision-making in data-driven environments. Throughout this lecture series, I encourage you to approach analytical information with curiosity, skepticism, and discipline, because effective analysis is not simply about generating numbers. It's about understanding what those numbers truly mean, what limitations they contain, and whether they genuinely support informed decisions. As technology continues to evolve, organizations increasingly depend on automated systems, predictive analytics, and real-time dashboards. Yet even advanced technologies cannot compensate for flawed data or poor analytical reasoning. This module will help you develop the critical mindset needed to evaluate evidence responsibly in professional environments. In this section of the module, we're going to examine how data quality and reliability influence analytical outcomes. This topic is critically important because modern organizations increasingly depend on data-driven systems to support planning, forecasting, operational management, and decision-making. However, analytical systems are only as effective as the quality of the information that enters them. Even advanced analytical models, dashboards, or artificial intelligence systems can produce misleading conclusions if the underlying data is inaccurate, incomplete, inconsistent, or biased. Because of this, understanding data quality is a fundamental requirement for responsible analysis. Let us begin with the concept of data quality itself. High-quality data is generally defined as data that is accurate, complete, consistent, relevant, and reliable. These characteristics determine whether the data can support trustworthy analysis and meaningful conclusions. If one or more of these characteristics is missing, then the confidence we place in the analytical results decreases significantly. Many organizations spend enormous amounts of money implementing analytics platforms, but they often underestimate the importance of maintaining dependable data sources. Accuracy refers to whether the data correctly represents real-world conditions. For example, if a hospital records incorrect patient information, or if a financial institution records inaccurate transaction amounts, then the resulting analysis will also be incorrect. Analytical systems cannot automatically distinguish between accurate and inaccurate information. They process whatever data is provided to them. Therefore, inaccurate data creates a direct pathway toward unreliable conclusions and potentially harmful decisions. Completeness is another essential component of data quality. Missing or incomplete data creates gaps that reduce confidence in analytical findings. Imagine a company attempting to analyze customer behavior while large portions of customer activity are missing from the dataset. The organization may incorrectly identify trends, misunderstand customer preferences, or fail to recognize emerging problems. Incomplete information can distort the overall picture and produce conclusions that appear valid while actually hiding uncertainty. Consistency is equally important because organizations often collect data from multiple departments, systems, and platforms. If the same information is recorded differently across systems, comparison becomes difficult and analytical reliability decreases. Inconsistent naming conventions, measurement standards, or reporting formats may produce conflicting interpretations. Consistent data allows analysts to compare information across environments in a meaningful way. Relevance also plays a major role in effective analytics. Organizations frequently possess enormous amounts of data, but not all of it is useful for every decision context. Relevant data focuses directly on the problem being analyzed. If analysts include unrelated information, the analysis may become unnecessarily complicated or misleading. Now let us discuss reliability. Reliable data produces stable and consistent results under similar conditions. Reliability is strengthened through standardized and repeatable data collection methods. If data collection procedures constantly change, then the resulting information may become difficult to trust. If different employees measure performance using different criteria, the organization may observe variations that reflect inconsistent methods rather than genuine changes in performance. Data quality problems can emerge from many different sources. Human error is one of the most common causes. Individual may accidentally enter incorrect information, omit important details, or misunderstand reporting procedures. Measurement limitations can also reduce quality. Sensors, surveys, and automated systems are not perfect and may introduce inaccuracies into datasets. System failures and biased collection methods can further weaken reliability over time. Because of these risks, decision makers must carefully evaluate data quality before interpreting analytical outputs. A visually impressive dashboard does not guarantee trustworthy conclusions. Analysts must ask important questions about where the data originated, how it was collected, whether it's complete, whether it's current, and whether biases may exist within the dataset. Ultimately, strong analytical outcomes depend on strong data foundations. Reliable analytics begins with accurate, complete, consistent, relevant, and dependable information. Organizations that prioritize data quality improve their ability to make informed decisions, reduce uncertainty, identify meaningful trends, and support responsible evidence-based reasoning. In this portion of the module, we will focus on interpreting common forms of analytical evidence used in reports and dashboards. Modern organizations generate massive amounts of data every day, and decision makers depend on analytical tools to transform that information into formats that are understandable, actionable, and efficient. Reports, dashboards, and visualizations help organizations summarize complex data sets, monitor performance, identify trends, and support strategic planning. However, interpreting analytical evidence correctly requires more than simply reading charts or observing numbers on a screen. Effective interpretation demands critical thinking, contextual understanding, and awareness of how the information was collected and analyzed. Let us begin by discussing reports. Reports are one of the most traditional and widely used forms of analytical evidence. Organizations use reports to summarize operational performance, financial results, customer behavior, production outcomes, risk assessments, and many other forms of organizational activity. Reports often contain tables, written explanations, charts, trend comparisons, and key performance indicators. These elements are designed to organize information in ways that support decision making and communication across departments. Key performance indicators, often called KPIs, are especially important because they provide measurable indicators of organizational performance. For example, a business might track sales growth, customer retention, production efficiency, or operational costs. However, KPIs must be interpreted carefully. A single performance metric rarely tells the complete story. Improvements in one area may create hidden problems in another area. Because of this, analysts must examine performance indicators within a broader organizational context rather than viewing them in isolation. Dashboards represent another major category of analytical evidence. Unlike static reports, dashboards often provide interactive and real-time or near real-time information. Dashboards allow users to monitor changing conditions continuously and explore data dynamically. For example, managers may filter information by region, department, time period, or product category to examine specific patterns more closely. This flexibility allows organizations to respond more quickly to operational changes and emerging issues. Visualizations are particularly powerful because they help human beings recognize patterns more efficiently than raw numerical tables alone. Bar charts, line graphs, and pie charts are commonly used to communicate relationships and trends. Line graphs are especially useful for showing changes over time, such as revenue growth, website traffic, or stock market performance. Bar charts are effective for comparing values across categories, such as sales across regions or performance across departments. Visualizations simplify large datasets and help audiences identify important relationships quickly. However, visualizations also present significant risks if they are designed improperly or interpreted carelessly. Charts can become misleading when scales are distorted, when selective information is presented, or when important context is omitted. For example, adjusting the scale of a graph may exaggerate minor differences and create the appearance of dramatic change. Similarly, presenting only favorable data while ignoring contradictory evidence can distort conclusions and influence decision-making unfairly. Another important issue involves understanding how the data itself was collected and analyzed. Analytical outputs are shaped by assumptions, methodologies, and processing decisions made during analysis. If analysts fail to understand these underlying assumptions, they may incorrectly interpret the results. Aggregated data also presents challenges because it may hide important variability or detailed patterns within subgroups. A summary average may appear stable while concealing significant differences across departments, populations, or time periods. Therefore, decision makers must evaluate analytical evidence critically and carefully. They should ask questions about methodology, assumptions, data quality, sampling procedures, and potential limitations before drawing conclusions. Analytical outputs should support evidence-based reasoning rather than replacing critical thinking. Ultimately, reports, dashboards, and visualizations are powerful tools for communicating analytical evidence, but their value depends on responsible interpretation. Effective analysts recognize both the strengths and the limitations of analytical presentations and understand that meaningful decision-making requires thoughtful evaluation rather than passive acceptance of displayed information. In this section of the module, we're going to analyze how data limitations can affect decision accuracy. One of the most important realities of analytical work is that real-world data sets are rarely perfect. Although analytical systems are often presented as objective and precise, the quality of their outputs depends heavily on the strengths and weaknesses of the underlying data. Uncertainty, bias, incompleteness, and measurement error are common challenges in nearly every analytical environment. As future professionals, analysts, and decision makers, it is essential to recognize that data limitations can significantly influence the reliability and fairness of conclusions. Let us begin with the issue of missing data. Missing information is one of the most common problems encountered in analytical systems. Incomplete data sets create gaps that reduce confidence in analytical findings and may distort the overall interpretation of results. For example, imagine a healthcare organization attempting to study patient outcomes while important medical records are absent from the dataset. The resulting analysis may fail to identify critical patterns or may produce conclusions that do not accurately represent reality. Missing data becomes especially problematic when certain groups are underrepresented or excluded entirely. If a dataset lacks sufficient information about particular populations, the resulting decisions may fail to reflect the experiences or needs of those groups. This issue is particularly important in areas such as hiring, lending, healthcare, public policy, and criminal justice, where analytical systems can influence significant human outcomes. When important populations are missing from the data, analytical conclusions may unintentionally reinforce inequality or bias. Bias itself is another major limitation that affects decision accuracy. Bias can enter analytical systems during data collection, processing, interpretation, or even through the assumptions made by analysts and organizations. For example, if data is collected primarily from a limited demographic group, the resulting analysis may not represent the broader population accurately. Similarly, biased survey wording, selective sampling methods, or inconsistent reporting procedures can distort analytical outcomes. Measurement errors also create substantial challenges in data analysis. Measurement error occurs when recorded values fail to reflect actual conditions accurately. Sensors may produce inaccurate readings, software systems may contain recording flaws, and human observers may unintentionally introduce inconsistencies during data entry or evaluation. Even small measurement errors can become significant when analytical systems process very large data sets or when organizations rely heavily on automated decision-making systems. Another important limitation involves the distinction between quantitative and qualitative information. Quantitative data focuses primarily on numerical measurements, statistics, and measurable variables. While numerical information is extremely valuable, it does not always capture the full complexity of human behavior, organizational culture, emotions and motivations, or social relationships. For example, employee satisfaction cannot always be fully understood through numerical survey scores alone. Important contextual factors may remain hidden when organizations rely exclusively on quantitative metrics. Because of this, relying only on numerical data can lead to incomplete or oversimplified decision making. Organizations must often combine quantitative analysis with qualitative insights, expert judgment, interviews, observations, and contextual understanding to develop more accurate conclusions. Analytical systems are powerful tools, but they cannot eliminate uncertainty entirely. Decision makers should therefore recognize the impact of missing data, bias, measurement error, and limited representation when interpreting analytical evidence. One effective strategy for reducing uncertainty involves using multiple information sources to validate conclusions. When independent datasets, methods, or observations produce similar findings, confidence in the results generally increases. Recognizing data limitations ultimately improves decision accuracy and reliability because it encourages critical thinking and cautious interpretation. Responsible analysts understand that uncertainty is a natural part of real-world data analysis. Rather than blindly trusting every analytical output, effective decision makers evaluate potential weaknesses, question assumptions, and consider alternative explanations before reaching conclusions. In data-driven environments, awareness of limitations is not a weakness. It is a fundamental requirement for responsible and informed decision making. In this final section of the module, we will evaluate the credibility of data sources used in analytical decision making. As organizations increasingly depend on data to guide strategic planning, forecasting, operational management, and policy development, the credibility of the information being used becomes critically important. Even sophisticated analytical systems and advanced models cannot produce trustworthy conclusions if the underlying data originates from unreliable or poorly documented sources. Because of this, evaluating source credibility is one of the most essential responsibilities of analysts, managers, researchers, and decision makers. Let us begin by discussing what makes a data source credible. Credible data sources are generally characterized by accuracy, consistency, transparency, reliability, and methodological rigor. These characteristics help determine whether the information can support dependable analysis, and informed decision making. If the source lacks transparency or contains questionable collection practices, then confidence in the resulting conclusions decreases substantially. One important indicator of credibility is the reputation of the organization providing the data. Information produced by government agencies, established research institutions, universities, recognized international organizations, and trusted companies is often considered more reliable than information obtained from unverified or unknown sources. Reputable organizations typically follow standardized collection procedures, quality assurance practices, and ethical guidelines that strengthen the reliability of their data. However, reputation alone is not sufficient. Analysts must also examine transparency. Transparency means that the source clearly explains how the data was collected, processed, analyzed, and interpreted. Credible sources usually provide detailed information about methodologies, sample sizes, data collection procedures, assumptions, limitations, and analytical techniques. Without this information, it becomes difficult to evaluate whether the conclusions are trustworthy or whether hidden weaknesses exist within the dataset. For example, imagine a survey reporting strong public support for a policy initiative. If the survey does not explain how participants were selected, how questions were worded, or how large the sample size was, then the reliability of the findings becomes questionable. Methodological details are essential because they allow analysts to evaluate whether the data collection process may have introduced bias or distortion. Consistency and reproducibility are also major indicators of source credibility. Reliable analytical methods should produce relatively stable and repeatable results under similar conditions. If repeated studies or analyses generate dramatically different conclusions without clear explanations, this may indicate methodological weaknesses, poor data quality, or hidden biases. Significant unexplained variations should encourage analysts to investigate further before accepting the findings as reliable evidence. Timeliness represents another important factor in evaluating data credibility. Outdated information may fail to reflect current conditions, trends, technologies, market environments, or population behaviors. In rapidly changing fields such as cybersecurity, healthcare, economics, or technology, relying on obsolete data can lead organizations toward ineffective or harmful decisions. Current and relevant data generally supports more accurate analysis because it reflects present realities more effectively. At the same time, even highly credible sources may contain limitations or potential biases. Analysts should never assume that a source is completely objective simply because it originates from a respected organization. Funding sources, political influences, organizational priorities, sampling limitations, and analytical assumptions can still affect outcomes. Responsible decision makers therefore evaluate evidence critically, even when working with trusted institutions. Ultimately, evaluating the credibility of data sources supports informed and responsible decision making. Strong analytical conclusions depend not only on technical analysis, but also on the trustworthiness of the information being analyzed. Effective analysts examine accuracy, transparency, consistency, methodology, timeliness, and potential bias before relying on data to support important decisions. In modern data-driven environments, critical evaluation of source credibility is essential because trustworthy decisions begin with trustworthy evidence.